Hey everyone, welcome back to the Bug No Jitsu. In today's video, we're tackling an interesting problem from LeetCode, Power of 2. We'll first break it down step by step, understand what it's asking, go through an example, and then solve it using two different approaches. First, a straightforward iterative method, and then an optimal bitwise method that works in constant time. Let's get started. The problem is simple but tests your understanding of numbers and binary representation. You are given an integer n, and you need to determine if it's a power of 2. That means n should be of the form 2 power k, where k is a non-negative integer, for example, 1, 2, 4, 8, 16, and so on. If it matches this pattern, return true, otherwise return false. Let's take n equals 16. We know that powers of 2 follow the pattern 1, 2, 4, 8, 16, 32, and so on. Here, 16 is exactly 2 power 4. Which means we take 2 and multiply it by itself 4 times. 2 times 2 times 2 times 2 equals to 16. Since it matches the definition of a power of 2, we return true. In my first method, I take a very direct approach. First, I handle an edge case. If the number is odd and not equal to 1, it cannot be a power of 2, so I immediately return false. Then I start from the smallest power of 2, which is 2 power 0 equal to 1, and keep increasing the power until I either find a match or exceed n. If at any point 2 power I equals n, we return true. If it overshoots n, we return false. This is a simple method, easy to understand, but it may take up to log 2, n, steps. The second approach is much faster and uses bitwise operations. Here's the trick: in binary form, a power of 2 always has exactly one bit set to 1, and all other bits are 0. For example, 1 is equal to 0001. 2 is equal to 0010. 4 is equal to 0100. 8 is equal to 1000. If you take a power of 2 and subtract 1, it flips all the bits after the single set bit. For instance, 8 minus 1 gives 7. If you and these two numbers together, the result is always 0 for powers of 2. This works in constant time, without any loops. Iterative method, time complexity is O, log n, because we check powers of 2 until we reach or exceed n. Space complexity is O, 1. Bitwise method, time complexity is O, 1, because it does a fixed number of operations regardless of n. Space complexity is O, 1. This problem is a great example of how mathematical properties of numbers can be combined with bitwise operations to achieve faster results. The iterative method is beginner-friendly and intuitive, while the bitwise method is optimal and elegant. In interviews, explaining why the bitwise trick works can really impress the interviewer. Memory-free check: the bitwise method uses constant memory, O1, space, and does not require any additional data structures, perfect for performance-critical or embedded systems. Real-world application: this check is not just theoretical, it's used in memory allocation, graphics rendering, cryptography, and determining if a number aligns with processor cache lines. Beginner versus pro approach: the iterative power check method is beginner-friendly and helps in understanding the concept, while the bitwise method is the industry standard for speed. That's it for today's problem. If you found this helpful, smash that like button, subscribe to Bug No Jitsu for more algorithm breakdowns, and share this video with your friends who are preparing for coding interviews. Thanks for watching, and I'll see you in the next one.